Students, today's lesson is on acceleration. Acceleration is one of the most confusing topics in all of physical science. To understand acceleration, you have to recall position, relative position, motion, speed, and velocity. Position is a point in space. What about relative position? So relative position is a point in space relative to or based on a reference point. So all points are relative to other points, so all positions are relative. Motion is defined as a change in position of an object. You have to have an object to have motion. Does that make sense? Yes. Do you have to have an object to have a position?
Yes.
No.
No.
There could be a position that has no object associated with that position. Like positions in space, most of them do not have objects there. Does that make sense?
Yes.
But in other words, in order to have motion, there must be an object to have motion. Got it?
Yes.
Speed is the rate of motion. It's the rate of change in position. Speed is how fast the motion takes place. Okay? New term that we haven't formally defined, velocity. Do y'all know what velocity is? Velocity is speed with direction. Velocity is speed with direction. Let me give you an example. Let's suppose you are at this building. Here. And you hear a report that there's a tornado that is 10 miles from you. And the tornado is traveling at a speed of 50 miles per hour. What should you do? Should you run away, go in the opposite direction? All right, students, the correct answer is, in this particular situation, you're not sure what to do. The reason why, you know the speed of the tornado, but do you know the velocity of the tornado? So you need the speed of the tornado, but you also need the velocity of the tornado. Remember, velocity is speed with direction. Remember that?
Yes.
So if the velocity of the tornado is 50 miles per hour south, what do you do? You just stay there. If this tornado is 10 miles away from you and it's traveling 50 miles per hour south, you're not in any danger at all. You might want to call some family or friends, but for you, you're not in danger because although this tornado has speed, it doesn't have the velocity where it would travel towards you. Do you understand the difference between speed and velocity?
Yes.
The speed of this tornado is 50 miles per hour. The velocity of this tornado is 50 miles per hour south. The position of this tornado is 10 miles east of you. You see the position, speed, and velocity? All right, now let's talk about acceleration. So acceleration is defined as the rate of change of velocity. A equals delta V over T. A equals delta V over T. Delta means what, class? Change. Delta means change. For example, if Johnny grows from 5'2" to 5'6", what is his change in height? 4 inches. How do you get that? You get his final height minus his initial height. Okay? So change is always the final minus the initial. Change in velocity is equal to the final velocity minus the initial velocity. Do you understand change in velocity? The F is for final, the V is for initial. And then acceleration is not just change in velocity, it's change in velocity over time. Does that make sense?
Yes.
Acceleration is change in velocity over time, okay? And so we're going to talk about 4 situations of acceleration. These 4 situations, if you don't think about them, will be very confusing, all right? And to illustrate these situations, I'm going to draw what I call a velocity number line. Do y'all recall the number line from elementary school?
Yes.
0, 1, 2, 3, 4. -1, -2, -3, -4. Does that sound familiar?
Yes.
That's just a basic number line. Now, I'm going to call this the velocity number line. Velocity, let's say, in meters per second. Okay? Now, first of all, let's take this as where the velocity is, what the speed is. Right now, the speed is about what, class?
0.
It's about 0, right?
Yes.
What is the object doing now?
Increasing velocity.
It's increasing in velocity. So this situation is positive velocity, but it's also positive acceleration. So positive velocity, positive acceleration. First of all, positive velocity means traveling forwards. Positive acceleration, in this case, means speeding up. Does that make sense? Okay, if the initial velocity was 0 meters per second, and the final velocity is 4 meters per second, and let's say that change in velocity took place over 1 second, the acceleration in that case would be 4 meters per second minus 0 meters per second divided by 1 second, which would give you what acceleration?
4 meters per second.
4 meters per second per second, okay? So that would be the units for acceleration, meters per second. Also, by the way, meters per second squared. If you do the math behind those units, you'll see that those seconds do not cancel. That's actually also meters per second squared. So that's a positive acceleration, means the car was traveling forwards and speeding up. Does that first scenario make sense?
Yes.
All right. Second scenario. Second scenario, let's say if the car goes from 4 meters per second back to 0 meters per second. This is positive velocity, negative acceleration. What do y'all think that means?
Because here's the velocity. You're still going to positive numbers on
going anywhere. It's not gaining any speed.
Not quite.
Constantly.
Half right.
You're gaining velocity
You're-
going backwards.
You're still,
Not quite.
You're still on the positive numbers on the
It's
same
moving
line, so the
constantly
velocity is
forward.
still
At a constant speed.
positive, but it's gaining speed backwards.
Okay. So I'm going to try it again. We started at 4 meters per second, and here's what the speed is doing.
Oh, you scared me forward.
You're losing speed, you're slowing down, right? So if you calculate the acceleration, let's say this change in velocity took place in 2 seconds. I'm just making up times. So the acceleration in this case would be, the final speed would be 0 meters per second. The initial speed would be 4 meters per second. The time in this case is 2 seconds. So the acceleration in this case is, notice this time the change in velocity is negative. Negative 4 meters per second in 2 seconds would be what kind of acceleration, y'all?
-2 meters per second.
Negative 2 meters per second, or negative 2 meters per second squared. Very good. So positive velocity, negative acceleration means going forwards, slowing down. The first scenario, positive velocity, positive acceleration, means going forwards, speeding up. The second example, positive velocity, negative acceleration, means going forwards and slowing down. Now the next two will be much more confusing than the first two. The next scenario, I promise you, you will be confused. Negative velocity, positive acceleration. Negative velocity, positive acceleration. All right, what do you think that means?
You are going backwards, but you're increasing speed.
Almost. Almost. Let me show you what it means. All right, notice right here, y'all, the range of velocities over here is negative, isn't it? Negative velocity does mean going backwards. So negative velocity means going backwards. But if your speedometer was doing this, notice your speed is approaching what value? 0. So if your speed is approaching 0, you're actually slowing down. So negative velocity, positive acceleration means going backwards, slowing down. Slowing down, I can prove it. The acceleration, let's say if you go from -4 meters per second to 0 meters per second. So if you're going from -4 meters per second to 0 meters per second, your final velocity is 0 meters per second. Your initial velocity is -4 meters per second. And let's say, for example, that happens over 2 seconds. Okay? So what is 0 minus -4? Positive 4. So that's 4 meters per second in 2 seconds, which will give you 2 meters per second, or 2 meters per second squared. That's a positive acceleration. So mathematically, it's positive. Even though mathematically it's positive, in reality what's happening here is this particular vehicle, this car, is approaching 0 miles per hour. It's actually slowing down. Okay? That's the confusing one. Negative velocity, positive acceleration means going backwards, slowing down. One more scenario, negative velocity, negative acceleration. Does anybody know what that means?
Oh,
Going backwards, getting faster.
It is. It's going backwards, speeding up. Notice, what's the value of speed doing this way? Is it slowing down?
No, it's getting
No.
backwards.
It's actually speeding up backwards. So this last scenario, negative velocity, negative acceleration, is actually speeding up backwards. An example would be, if you did a calculation, first of all, the initial velocity was, let's say, 0 meters per second. The final velocity, let's say, -4 meters per second. So -4 meters per second is the final. The initial velocity is 0 meters per second. If that change takes place over, let's say, 1 second, then the acceleration in this case would be -4 meters per second over 1 second, which would be what, class? -4 meters per second, which is also -4 meters per second squared. Okay? So in summary, if you have positive velocity, positive acceleration, that means you're going forwards, speeding up. If you have positive velocity, negative acceleration, that means you're going forwards, slowing down. If you have negative velocity, positive acceleration, that means you're going backwards, slowing down. If you have negative velocity, negative acceleration, that means you're going backwards, speeding up. One more summary way to understand this for students that just need help with remembering all of this is, if the sign for velocity and acceleration are the same signs, you're speeding up. This case, you're speeding up. This case, you're speeding up. Case 1 and case 4. If the velocity and acceleration signs are opposite, you're doing what? You're slowing down. These are slowing down. These are slowing down. So that's pretty much acceleration as it relates to position, relative position, speed, velocity. Thank you.